I'm Tim Wagner. I've been involved with serverless from its earliest days, when I wrote the original business plan for AWS Lambda. And my serverless journey is far from over, as you'll hear more about in a bit. But to put all of that in context, let's take a look at the evolution of serverless, starting from its past, through its present-day growth, and then into its exciting future. While the actual term serverless came later, the technology that we now know as things like AWS Lambda started all the way back in 2013. I'd been hired into the AWS S3 team, and S3 was still relatively new, but it had come up with a powerful new way of delivering cloud storage capabilities, not by emulating on-prem file storage devices, but instead through a simple, easy-to-use API. And in those days, it really was just get, put, and list. But that first step toward managed services had been taken. At that time, though, functions weren't even a concept. Jamstack and Netlify were still in the future, and when it came to compute, the world was building heavyweight web servers, using those techniques and technologies that they'd inherited from on-prem data centers, just ported over to the cloud with minimal changes. It really was that era of lift and shift. And because of that, the dominant design question on everyone's mind was, how do we make web servers easier to deploy and manage? And there were a lot of solutions, like Google's App Engine, Heroku, open source and commercial flavors, cloud and on-prem variants. But it turns out, for the long term, that was the wrong question to be asking. Because building a better cloud, one that worked more like S3 and less like an on-prem data center, wasn't going to be answered by more and more complicated PaaS approaches to ever more complicated web apps. So instead, we took a step back and wondered, are we even asking the right question here? And it turns out there were better questions to ask. And as we talked to customers, we started to hear them. Questions like, what's an easier way to run code in the cloud? What's a better way of thinking about it than deploying a server image? What's the compute equivalent of S3? And what might a future application look like if you could start all over from scratch with all the power of the public cloud to draw on? And it turns out there was a simple, powerful answer once we started asking the right questions. That answer, of course, became Lambda. It's 2014. Lambda launches. It's 2015. Lambda goes GA. But like any new concept, it needs to find its product market fit. We had launched it hoping to make it the centerpiece of a programming model around events and asynchronous event handlers from sources like S3, DynamoDB, Amazon Kinesis, and others. That idea totally turned out to work, but it took longer than expected. The learning curve to get people to consider a new way of crafting applications just took a while. Today, there are dozens of event sources for Lambda, not just other AWS services, but also third parties. Lambda was also a sibling team, not just to API Gateway, but also to the newly created AWS mobile service. And we wanted to create a strong partnership between them. Facebook Parse had first mover advantage in that market, and AWS was working to catch up. But although this led to some important features like synchronous invokes, Lambda's role in enabling mobile apps in a big way would really have to wait until AppSync and Amplify came onto the scene much later. It turns out the winner in those early days was cron jobs. Yep, a total sleeper hit. Not a surprise that it worked, but that it proved so popular so fast. Even today, companies often start their serverless journey with a better cron. So much for the past. Let's move on to the present. Here in the present, it's the age of features. Serverless functionality is getting delivered fast and furiously, from features in existing services to integrations with other technologies like SQL databases, to innovative new ideas for what serverless even means, like Docker images for serverless, stateless front-end fleets. And many of these features are critical to customer adoption because they make entirely new categories of applications possible when they come out. The recent launch of EFS integration for Lambda is a perfect example. S3 is a fantastic service, but much of the application code out there requires a Unix-style file system in order to operate. Lambda's layer feature solves that problem for code, and its /temp offers a small amount of file system-based scratch space, but what if you need access to gigabytes or even terabytes of storage to perform a computation? Well, up to a few weeks ago, you were effectively locked out of attempting a serverless solution for that. EFS integration is also important to think about in terms of the future of serverless. In essence, it matches Lambda's infinite compute with an infinite disk drive, creating the potential for supercomputer-like capabilities. More on that in a little bit. As in 2013, though, there are all sorts of wrong questions. The right question to be asking in the present, frankly, is just as important as the one that started us down this road way back when. And it is, why do developers still turn to servers and containers, even though they're complicated, even though they're expensive, even though they're difficult to own and operate and manage? And the answer is that this age isn't over yet. That search to make serverless approaches simultaneously powerful and simple isn't finished. It's a real tricky balance, because often simplicity can come at the expense of flexibility. And sometimes that's okay. For example, I'm all right with not having the ability to pick my own EC2 instance as long as AWS can do a good job of that for me. But sometimes it's harder to pull that off, especially when it requires compromising ideas like statelessness. And this set of trade-offs is a useful lens for thinking about the key Lambda features that AWS launched at the last reInvent. So customers need certain outcomes in their applications. For example, a guarantee that latency will meet their end user expectations, or that they can use a SQL database easily and in a performant way. AWS's last set of reInvent launches for serverless were designed to find those places where servers and containers still had this differentiated advantage, and to close that gap for users of serverless applications. Done right, this gives all of us as application developers the best of both worlds. Serverless apps that are still simple to use, but that also possess all of the capabilities like a Unix file system that are needed to run conventional apps with great user experiences. But put too much state into the system, or add features like being able to address a Lambda, for example, and you turn Lambda into a mini server, recreating all the challenges that it works so hard to free developers from over the years. There's still more to do. I certainly have my own wish list for things that would make using Lambda, step functions, and other AWS services even easier. Some of these items are simply making common development tasks simpler, like the ability to copy functions or to get a function to run exactly once, or built-in support for gRPC. But other items on this list challenge the very definition of serverless and require hard work, not just in their engineering, but in designing serverless solutions that recreate these application paradigms we all depend on, like file systems, without giving in to making them feel like they're running on a server. Handling sharded data streams is one such example. Today, Lambda can easily plug into Kinesis to process data. And yet, simple tasks, like keeping a running sum or a running average, can't be done in memory the way they can in other stream-based processors. Finding a middle ground between going back to servers or being so stateless that simple tasks are hard to code up is tricky, and will undoubtedly keep cloud vendors busy for some time to come. Zooming out from the micro to the macro environment, the present day is also a time when many people are innovating in the serverless space, not just the cloud vendors. Enterprise integration, security, monitoring, frameworks and patterns for application construction and delivery. No innovation or massive change on the order of serverless happens in isolation. The growing serverless ecosystem is also critical for helping customers turn the Lego bricks of AWS services into real business solutions. Scaling out to help more customers adopt serverless approaches can only happen with the ISVs, solution integrators, consultants, educators, and many others who can enlist and engage the breadth of the entire developer community. The bottom line here is that the more innovative and disruptive an idea is, the more distance people have to cover to put it in practice, and the more folks it takes to make that happen. All right, we've talked about the past, we've talked about the present. Now let's see what the future has in store for us. The chapters as yet unwritten, the exciting innovations yet to come, the future of serverless. But to start talking about the future, we first need to acknowledge the passing of an era. For many of us, one of the unquestionable tenets of our professional careers was Moore's Law, the idea that computing power would keep on doubling every 2 years or so. That engine of change was, quite literally, bankable for many, many years, but it's come to an end. If you haven't heard the bad news, I'm here to break it to you. Moore's Law is dead. Memory and individual CPUs are about as good as they're going to get, at least until quantum really becomes a thing. And that has some serious implications. First and most obviously, vertical scaling, that hallmark of the last generation of enterprise solutions, will hit a wall. I'm not here to say that there will never be more EC2 instance types, but the idea that you can keep on doubling performance or compute capacity simply by upgrading your RIs every couple of years is just not going to be a viable scaling plan for large companies. And memory, unfortunately, is in largely the same boat. The party days of ever-shrinking costs and ever-growing compute power, in that sense, are coming to an end. But there's some good news. Moore's Law lives on in that third leg of the stool, networking. Networking performance in data centers, unlike the core CPU and memories, keeps getting better. So, what does this tell us? Well, first, stagnant growth in CPU and memory, while networking keeps getting better, swings the pendulum from shared memory multiprocessing to networks of servers in terms of performance. In other words, as networking power improves relative to CPU and memory speeds, distributed systems get more and more attractive as the parallel processing platform of choice. Now, who does this favor? Well, where can one find a ton, more or less literally, of silicon connected with high-speed networks along with an easy-to-use programming and deployment model? I think I have an idea. But, there's always a but, right? But, most of what we know from 50 years of distributed computing research is suddenly based on the wrong model. It treats capacity, the size and number of machines, as fixed, but the time that they're in service as effectively infinite. And serverless approaches are the exact opposite. Capacity is effectively infinite, but duration, the time that an algorithm can occupy a machine, is limited. Guess it might be time for some new research, right? And fortunately, we are getting just that. Berkeley, Stanford, UCSD, and other academic and commercial research centers have started taking the serverless compute model and its unique opportunities and challenges as a topic of serious investigation. Fast linear algebra transforms, massively parallel make systems, the world's fastest known video transcoder, ephemeral storage systems that match the flexibility of cloud functions. All of these have been researched and developed in universities over the last few years. The hottest area of supercomputer research isn't a supercomputer, it's AWS Lambda. It basically took us 8 years to get asynchronous event handlers as a programming model into the hands of developers in its current, fully fleshed out form. It's going to take at least that long to build the serverless supercomputer because there are a lot of moving parts. At the foundational levels, cloud vendors need to provide more stable and performant networking bandwidth. One of the reasons this is on my wish list for AWS for reInvent. At the top of this stack, domain-specific algorithms in biology, physics, math, AI, and other areas will need to be developed that can take advantage of the serverless supercomputer approach. And in between, there's a whole class of core functionality that has to be productized and performance optimized, just as happened for conventional servers with Hadoop and Spark frameworks. Real-time schedulers, executable data flow graphs, peer-to-peer networking, which I've had the privilege to work on a bit, and much more will all be needed in order to make this new supercomputer stack a reality. And by the way, this supercomputer is going to be the greenest execution environment ever created, thanks to its multi-tenancy. So, the future is starting to come into focus. Supercomputers are going to be serverless, and that power is going to exist not just for some privileged few. It'll be democratized into every user and every account in the public cloud. Next up, let's talk about SaaS. So there used to be this joke. How many software developers does it take to change a light bulb? And the answer? None, because that's a hardware problem. And indeed, for many years, the most challenging part of creating software was creating the hardware on which it ran. Go back 20 years, and starting a new software company meant you needed a massive team. Because anytime fiber, networking, colo security, racks are involved, you need a range of professional skills to span those requirements. At Coinbase, we built a high-speed, low-latency trading engine with a team in Chicago. Some of the smartest folks I've worked with, best equipment, top-notch designs, and even with every modern advantage, we still needed several dozen people. Infrastructure is just like that, and the lower you go, the more specialties you need. So let's look at the point roughly when AWS launches Lambda. Suddenly, there's a nearly order of magnitude drop in staffing a software company because cloud, Once somebody else lays the network, orders the routers, racks the servers, checks the power, pays for the HVAC, updates the firmware, and all the other thousands of tasks needed to build a data center installation, the purely hardware aspect of the problem goes away, along with the people who have to do it. But unfortunately, the undifferentiated lifting doesn't completely disappear. Scaling EC2 across AZs, still need someone to worry about that. Upgrade your Linux image periodically for security purposes, yep, got to do that too. 24/7 ops, a copy of your environment in every region, a staging system to match production, and on, none of which has anything particular to do with whatever business it is you're actually in. So by now, you've probably heard the fabled Amazon 2 pizza teams model to describe the size of the team that owns and operates a service. But if you stop to think about why is that? Why does it take 2 pizzas worth of people to get and keep a service up and running? I once heard it expressed as vacation, sick, primary, secondary, everything else. In other words, someone's off on holiday, someone's homesick, someone's operating the service, someone's on standby when that primary person needs to sleep, and then maybe you get 1 or 2 or at most 3 people left behind to build out whatever new features the business might require. So basically, one of those 2 pizzas is undifferentiated heavy eating. Serverless changes those dynamics in a dramatic way. When I worked on Lambda, that is when I used EC2 to build a service, it took us at least a month, often with multiple developers, to launch a new region back in 2015. Last month, I rolled out my startup's product to 10 regions worldwide in under 5 minutes by myself, just by updating an array of region names using the AWS CDK. That leverage of serverless and config as code is almost magical. So what does this have to do with SaaS? Well, first, let's look at what you might call classic SaaS. Let's say you want to offer a service to companies such as running payroll. By the way, huge shout out to Gusto. Love you guys. So a customer like me gets an expert on the topic, like payroll, without having to pay much and without having to hire someone to go run payroll. The company gets to use a single database table to store everyone's info, making the marginal cost of supporting a net new customer virtually zero. And everyone gets a healthy abstraction layer. The Run Payroll button on the web page triggers all kinds of complicated back-end services, which as a customer I get to ignore almost completely. And meanwhile, the developers of that service get to ignore virtually everything about my environment. So that works if your SaaS is a website with a database. But could you build infrastructure that way? Could you build an actual database that way? Well, the benefits would still be the same. The customers would get a ton of leverage. Both customer and implementer would enjoy an API-based abstraction layer. And everyone would benefit from economies of scale on a single shared implementation versus a custom implementation per customer. But what about multi-tenancy? It's one thing to store some business data in a single database, but that starts to break down when your product requires operational isolation across customers, insulation from noisy neighbor experiences, plus running on trusted code is super tricky to pull off. So the solution? STAMT, single-tenanted accounts running on multi-tenanted infrastructure. In other words, build your infrastructure using managed services from a cloud vendor, but isolate customers into individual accounts. Now, the single-tenanted design ensures that you have all the operational and security isolation that the public cloud is capable of providing between any 2 end users, just as if you gave them completely independent servers of their own. But what you're actually getting for an implementation is multi-tenanted, and the multi-tenanted nature of managed services used to build your implementation means you get the low-cost, pay-per-request, instant-on scalability, built-in fault tolerance, basically all the advantages of your own serverless apps shining through into the product and the experience for your users. Secure, isolated, and serverless, all at the same time. So my SaaS conclusions/predictions, in the long run, SaaS is the only delivery model that survives. And SaaS companies of any flavor built on a serverless foundation are going to enjoy a competitive advantage, lower costs, and improve customer outcomes. And most importantly, the STAMT model enables SaaS infrastructure products so that eventually any form of infrastructure can be built serverlessly and deployed and delivered via SaaS. Serverless supercomputers, supercharged SaaS, and now I'd like to tell you about something that I've been working on. I mentioned at the beginning that my serverless journey wasn't over. I haven't been this excited about the serverless space since I first got up on stage in 2014 to launch Lambda. But then, as now, to understand the motivation, we have to ask the right questions. Back in 2013, the wrong question was how to deploy a monolithic web app a little bit better. So, as we look forward to the future of application development over the next 10 years, what's the wrong question today? And I'll tell you, some of you are not going to like my answer. But as Jeff Bezos likes to say, sometimes you have to be willing to be misunderstood for a while. Because I assert that the wrong question to answer today is, how do I make my code portable? It seems like a reasonable question. I mean, after all, portable code would be insurance against bad behavior by a vendor and would at least give companies a fighting chance to create systems that span clouds and companies, albeit with a lot of DIY build-out. But portability is a red herring. It's a pursuit that has led to staggering complexity. It's caused companies to steer clear of Lambda and other serverless offerings out of fear and doubt. Bad behavior by a few vendors encouraged an entire generation of developers and business owners to seek the least common denominator just to protect themselves at huge cost. Now let's be clear, there are real business problems here, but those problems aren't about porting code from one cloud to another in some doomsday scenario. The real business problem, and the right question to be asking, is how can we share data and code effectively, even when it crosses companies, clouds, regions, and technology stacks, and without giving up on the best, most powerful, most cost-effective offerings that public cloud vendors are capable of delivering? Why is it so challenging to build applications that cross ownership, cloud, and regional lines? Partly it's about what existing approaches have chosen to focus on and what they've ignored. Let's take a look at two axes. On the vertical axis, we'll put scale. If you were to take a single box deployment as a starting point in the lower left, you move up this dimension. That is, you add scalability to a solution through horizontal scaling. This is how the public cloud vendors build and deliver services, especially fully managed services. They take commodity hardware and create massively multi-tenanted services like S3, Lambda, and DynamoDB on AWS. And here's the important bit. Adding more hardware to these implementations increases their capacity and throughput. Despite their amazing scalability, their rich feature sets, and broad adoption, services like Lambda do have an important limitation. Every line of their code assumes a single owner model. So when two companies or two regions or another cloud wants to share code and data, AWS isn't doing anything in particular to help. It's understandable. For much of the cloud's history, the goal has been to create isolation and security between those accounts. But then when you want to share something, it's not a particularly helpful model. Now let's look at the horizontal axis. Here we put degree of replication. That is, the ability to reliably share code and especially data. Mobile clients and web browsers do this all the time, and a more recent back-end example is blockchains. At its core, a blockchain is just a peer-to-peer sharing platform that maintains a fully replicated, totally ordered database on every node. As a modelful state, that's great. An immutable, tamper-proof ledger and a copy of the application state on every machine that's guaranteed to be identical. On the downside, the deployment model is impoverished. A single browser or a single blockchain node is inherently limited to one device or one server, run out of CPU, memory, disk, or network bandwidth, and it's game over. Add more machines to this network, and unlike a cloud service, things will get slower and weaker rather than stronger, faster, and bigger. Unfortunately, today you have to pick one axis, a replicated data model that has no ability to scale, or a highly scalable service that can only operate in a single account, with anything more left as a DIY project. But what if you could have both? What if there were a platform that offered all the scalability of services like Lambda, DynamoDB, and S3, but with the replicated data model of a distributed ledger, and then tied it all together in an easy-to-use programming model? This was the question that my co-founder, Shruti Rao, former business development manager for Amazon Managed Blockchain, and I found ourselves asking over and over again last year. Having experienced both Lambda and blockchain services, we wondered if there wasn't a better way, one that could combine them both. And once we asked that right question, Vendia was born. Vendia's application model builds on everything we know and love about serverless. everything in our implementation, both the pieces we own and operate and those we build for every portion of an application, is entirely serverless. By following the STAMP model, we get all the advantages of account-based isolation and all the serverless advantages of implementation. At the same time, we address the two overarching limitations of today's serverless offerings: their proprietary, single-vendor nature, and the lack of a simple, built-in state model. Unlike a Lambda function, which is limited to a single region, a single account, and of course a single cloud, every Vendia application is inherently multi-account, multi-region, and multi-cloud. And unlike Lambda functions where managing state is a do-it-yourself project, Vendia apps come with full support for application state built in, an immutable, fully ordered, tamper-proof ledger, and a replicated copy of all application state in every cloud, account, and region in which the application wants to operate. Vendia's application model also builds on everything we love about dApps, while getting rid of some of the things we don't like so much, like energy-hungry proof-of-work algorithms, hard-to-learn and use languages like Solidity, and their general inability to scale beyond a handful of transactions per second. Like blockchain-based applications, though, Vendia apps can run in any public cloud. Their owners aren't tied to any individual vendor, and they can easily collaborate with other companies, departments, or applications that may have chosen to build on a different cloud or technology platform. As with dApps, mutations are first-class objects, with full provenance tracking and ACID semantics for updates, making it easy to write code that requires strong ordering and consistency guarantees, like financial transactions and IoT control operations. And answering questions like, who made this change, or even backing out of a change to an earlier version, are all easily accomplished. But unlike all other existing blockchains, every Vendia node is serverless, running on hundreds, thousands, even tens of thousands of machines under the covers to provide low latency, scalable performance with zero ops and no server deployment hassles. And unlike most blockchains and dApps, Vendia takes enterprise integration seriously, making it trivial to integrate with public cloud services like Lambda, S3, Event Hub, SQS, Kinesis, Aurora, and more. We already knew that Lambda and other serverless approaches were great at dealing with events, so we also made sure to build that in as well. Finally, we knew many developers would never have the time to learn a new language, so we made it possible to use Lambda functions to write shared code, or if you prefer the term, smart contracts, in any language, completely eliminating the learning curve to get started. We called our company Vendia to suggest Venn diagrams, enabling companies to share code and data more effectively. We call this new model Universal Apps, or Unis for short, the best of serverless and the best of distributed apps together. And while Unis run on the public cloud, make no mistake, they are not just a big centralized database. Every node in every application is a fully decentralized, customer-isolated STAMP implementation. Other than user registration and deployment metadata, no customer data is ever centralized or shared with Vendia. And like legacy blockchains, Unis offer a full consensus model that ensures that different companies can reliably share data in a controlled fashion without ever having to trust each other. In fact, the only thing participants need to trust is their respective public cloud service provider. One of the key advantages of building on a serverless foundation is that we can take advantage of the cloud's virtually unlimited storage and compute capacity. With a conventional blockchain like Hyperledger, once you run out of space to store a ledger, it's difficult to perform an in-place upgrade. But storing a ledger in a NoSQL database like DynamoDB means that not only can you access arbitrary amounts of scaling capacity, you can also store as much data as you need to without ever hitting a limit. Similarly, to speed up transaction processing, we can fire off multiple Lambda functions in parallel. Try that trick with your favorite blockchain. While I clearly get very excited by the technology, it's also important to think about where Unis sit in the broader portfolio of an enterprise's IT stack. One of the most common challenges we hear from customers in virtually every industry, automotive, food and beverage, IT, logistics, is that they need an easier way to break through information silos. And while they need to share more, they also need to retain control, especially in a world where PII needs to be handled carefully and in compliance with regulations like GDPR. these aren't new problems for corporations. In fact, these challenges predate computers. But these problems have suddenly become far more pressing. AI/ML training, supply chain optimization, and data analytics have quickly morphed from nice-to-haves to competitive requirements. Fail to optimize your business or leave your supply chain to the vagaries of an uncertain macroeconomy, and your competitor may be taking over your business tomorrow. Today, 80% of a company's data lives outside its four walls. We call this the dispersed data problem. And it's a crucial one for companies to solve. Imagine trying to train an ML model on only 20% of its data. Powering these critical processes means having access to all the data, regardless of where it lives. And unlike most data shared through REST APIs, that data needs to be complete, consistent, and up to date at all times, or the analyses that run on it will themselves be incomplete, inconsistent, and outdated. At the same time, creating powerful outcomes needs to get easier, not harder. Using Vendia, challenges like creating a virtual data lake that spans different companies, clouds, and continents is as simple as writing a CRUD web app. In fact, we wrote one in under 200 lines of code using an early version of our platform. None of this would be useful without an easy developer experience. Apart from their inability to scale, one of the worst things about existing blockchains is that they generally require writing code and configuring server infrastructure just to stand up the moral equivalent of a multi-party database. That's not how people interact with a centralized database. You can walk up to a SQL database, give it a schema, and have a production-grade table in a few minutes without ever writing a line of code. In fact, without even knowing how to write a line of code. Vendia works the same way. Provide a JSON schema, and we compile it into a multi-node, multi-account serverless cloud deployment within a few minutes. No coding required. We built it as a compiler that understands data models and translates them into strongly typed assets, such as AppSync models. Speaking of AppSync and GraphQL, we also wanted to short-circuit all the common things developers need in 2020. Instead of a box of Legos, we just built in all the most important elements right out of the box. So rather than leave web and mobile integration as an exercise to the reader, we made hooking up web and mobile clients trivial. Every Vendia node offers an AppSync integration hub that's ready to go. Transaction entry is as simple as sending a mutation to a GraphQL API. Reading state, or the ledger itself, is as simple as writing a GraphQL query. And getting real-time notifications is as easy as hooking up a GraphQL subscription to any client. We also realized that not all data comes in the form of strings, numbers, and booleans. So we built in support for multimedia files and large datasets using S3 on AWS and similar blob stores on other platforms. Despite their difference in size, these objects enjoy all the same benefits as simple atomic types, including tamper-proof hash codes, full versioning, and controlled replication policies. Vendia's SaaS-based deployment model also means there's no need to integrate resources into an already complicated IT infrastructure portfolio. We place each node into a vended, segregated account, and then authorize your existing account to use it, completely eliminating even that small amount of operational overhead that serverless resources might require. When you work with multiple clouds, instead of insisting on a least common denominator approach like Kubernetes, Vendia lets you use the best and brightest the cloud has to offer. Like Lambdas? Great! Write your smart contracts in them. Need to access data on Google? No problem. Like the ease with which Azure Logic apps let you pull Twitter feeds? Great. Build that ingest on Azure, share the data with the rest of your application running on AWS, Google, or other clouds. One of the most astonishing things about working on AWS Lambda was seeing customers come up with ways to use it that we never envisioned, or in some cases didn't even believe possible, like building the world's fastest video transcoder. With Unis, you have all the power of the serverless resources you already know and love, like Lambdas, step functions, SQS, S3, DynamoDB, and more, plus the power to work with other clouds, work seamlessly across accounts and regions, and share data across different companies without requiring a trust model. Want a superpowered API that automatically keeps data on both sides consistent? Easy to build. An IoT engine that can ingest data from AWS but store it in a Google database? No problem. Even simple CRUB web apps get a makeover with easier web and mobile connectivity and built-in features like cross-region data management. We're really excited to share our early access with developers and see what amazing things others will come up with. Serverless has come a long way. From those first baby steps when we launched Lambda as a preview in 2014, but more than any one technology, serverless is a mission, a vision to make enterprise applications easy to develop, efficient to own and operate, and above all, to democratize the power that the public cloud has to offer to all developers and all organizations. And the future of serverless has never looked brighter. With increasing expressive and computational power along with access to unlimited file system storage, we'll be able to tackle larger and more complex problems than ever before, without the hassle of servers and containers. SaaS-based software delivery is similarly becoming simpler and more powerful than ever, enabling anyone with an idea and a basic knowledge of a programming language to create a software company that enjoys the same rigorous fault tolerance, scale, isolation, and security of an Amazon, Microsoft, or Google product. And universal apps are eliminating walled gardens, enabling companies and organizations to share code and data across clouds while retaining the benefits of serverless resources, the best, most powerful, most innovative capabilities that each of the public cloud providers has to offer. I've had the amazing privilege to be there at the start of the AWS serverless journey, to have played a part in the features and capabilities here in the present, and now to be the co-founder of a company taking serverless and distributed apps to the next level. I can't think of a better job, and I can't wait to see the amazing things that will come next. To learn more about the latest stage of my serverless journey, visit Vendia.net, sign up to get early access to our service, and follow us on Twitter, LinkedIn, and Medium. Thank you. And above all, go serverless.